Hello everyone. Today my topic is research on stock forecasting under different methods. The first part is data selection and presentation. The goal of my project is to predict the future movement of stocks. Considering that the stocks are cyclical and time series, I try to use different model methods to train the data and predict the closing price as the result and evaluation. First, I choose the stock of Amazon as a training object. In the selection of data features, I first use the daily opening price, closing price, highest and lowest price of the stock for training. And there are a small number of outliers showing the closing price. The density distribution of closing price as shown doesn't look normal, but rather exponential. The next part is model building and training. Using SVM, I get a prediction that looks good, but is not good enough to meet our expectations. Then I'm looking to use another time series approach to achieve the goal and add some variance factor. The ratio of the highest price, the lowest price, the opening price to the closing price for the day. And the next step is to use LSTM for training and also get good results. And obviously, random forest can not predict what happens outside of the training data. So we can find that this red line can reach the top because of the limitation of the training data. And this is also what I was worried about when choosing variables and parameters before. There may be a series of problems for fitting purely numerical numbers. So considering the characteristics of stock dynamic changes, I think it is possible to create a set of variables representing the rate of change to replace the original numerical transformation. And after change the variables, I got this result. Looks better. And then we combine three forecasts into one graph and have this comparison. Then compare the MSE and time consuming of the three models. We find that LSTM takes the longest time, but SVM has the best MSE performance. And the next part is predict longer-term stock price. And then we try to change thinking and set new features as a variable. We try to use day 1, 2, 3 to predict day 6 and day 2, 3, 4 to predict day 7. And then we create a new data frame suitable for predicting the stock situation in next 3 days, including all the data change rates of the first 3 days and the change rate of the last day as training data, and the stock change rate after 3 days as predictor variables. And then we combine those three forecasts into one graph and compare their fit to the test data. It is not difficult to find that LSTM has excellent performance. In the MSE comparison, we can find that comparing the performance of MSE in the previous data samples, a surprising result was obtained. the MSE of LSTM was very high or even higher than SVM when the actual value was predicted before. But now LSTM has a very low MSE. This shows that the selection and processing of data also play an important role in the optimization of the model. And according to time-consuming comparison, we can find that LSTM still spends the longest time. The next part is model validation. Then we choose Apple stock price as the forecast object. It is found that there is no obvious correlation between the price difference changes between the two stocks, but there is a certain relationship between the stock price changes. And this is a macro link caused by the stock market and the economic situation. So it is precisely because of the above two characteristics that I choose this related stock for testing. Then we combine those three forecasts into one graph again. Unsurprisingly, similar to previous predictions, LSTM has the best fit. But what is surprising is that the model still has an excellent prediction effect after replacing the data. The next step is LSTM model to predict other stocks. Then the data of three other companies were selected for prediction, namely Google, Microsoft, and Netflix. And we still get good prediction results with the help of LSTM and shown in the figure. Combining the LSTM predictions of the two companies obtained in the previous part, plus the results of the three companies obtained in this part, the MSE is combined for research. Since the model is still the previously trained Amazon model, the comparison is only to compare their MSE, and there is no need for time-consuming research. For the analysis of the degree of MSE dispersion on the results, I think there are many factors. The first is to observe that Amazon's training model has a higher MSE for Netflix prediction, largely because the two companies do not have many intersections and there is a different linear correlation of 0.1366 between the two. Then Apple and Microsoft followed, and the conclusion from the data is roughly the same. The best performing Google predicts MSE even better than Amazon in the test data. This phenomenon is very interesting and no conclusions can be drawn based on the previous correlation data between the two. I think it may be because these two companies are both internet companies and both have a certain level of physical industry. So they are highly competitive and cooperative. And the final part is conclusion and the first conclusion that can be drawn from this project is that the transformation parameters has a high improvement for model prediction. By using the rate of change for prediction, it is far more general than the actual value prediction. Secondly, the comparison between models by comparing MSE and time consumption. We can find that LSTM consumes the most training time but has the best results. SVM has the shortest training time and slightly less than random forest but obtains less MSE in prediction than RF. Finally, the migration of the LSTM model is studied, and I believe that after analyzing the relationship between new data and training samples, it can be concluded to some extent that the LSTM model has better migration in stock prediction and even other time series models. That's all. Thank you.